Hi everybody, good afternoon and welcome to the second session of the first season of Técnico MasterTalks. Today's session is dedicated to the Department of Electrical and Computer Engineering. I'm Beatriz and I'm an aerospace engineering master student, so I'm also a student of this department and I'll be moderating this talk. We'll have some time for your questions at the end of the talk, and then we encourage you to know more about the department's masters outside in the atrium, as well as international opportunities and career development and student support. First of all, we'd like to thank Professor Mário for accepting our invite to be here with us today. Professor Mário holds the title of Distinguished Professor of Técnico and is also Fitzai Chair in Machine Learning. He's a coordinator of the thematic area Information and Data Science at the Institute of Telecommunications. His research interests include machine learning, optimization, and signal processing. He has received several distinctions, including the titles of Fellow from the Institute of Electrical and Electronics Engineers, the International Association for Pattern Recognition, the European Association for Signal Processing, and the European Laboratory for Learning and Intelligence Systems. He is a member of the Portuguese Academy of Engineering and the Lisbon Academy of Science. We'll have the pleasure to hear what Professor Mário has to say about how electrical and computer engineering underpins key technologies in health, transport, communications, media, energy, industry, agriculture, entertainment, space, and deep sea explorations, and how we, as students, can be part of this transformation. Professor Mário, I guess the stage is yours.
Thank you. So thank you for the invitation to the organizers of this series of events. Hello, everybody. So it's great to see so many students, so many colleagues. So I don't know why the students are all in the front rows and the colleagues are in the back. It's okay. So what I'll try to do, I spent a lot of time thinking what to do with this talk, because it's not a standard talk. So I was told, well, you should talk about your work and how exciting your work is. And I said that's not a good idea, because it's not representative of everything that's done in the department. Then I tried to cover most of what's done in the department, which is also not an easy task, because we're almost 100 people, 100 professors working in very different areas. So it's a very, very wide range of applications and technologies that is covered in the department. It's a very broad, so it was very hard for me to select what to show. So I used a very pragmatic approach, which was I'm going to cover a set of master theses, because I'm going to stay at the work that's done at the master thesis. I'm not going to go into PhD level work. I think it's more interesting for you. And so my basic selection rule was whatever I have a small video describing the work, I will include. So there are some small videos about the work, and then in the end, I'll talk a little bit about my own work. And some other topics that I think are interesting that don't have video support. I won't spend a lot of time on the videos. I will basically use them to show topics that are on which people are working or have been working in recent years. But before that, so let me see how this moves. Okay, so this was my own slide, the picture that I took about the Department of Electrical and Computer Engineering. And of course, I think the first question is, if the slide moves, what the hell is electrical and computer engineering? So you may ask yourselves, yeah, I should speak louder, thank you. What is electrical and computer engineering? Okay, now I could ask you for a definition, but I'm not going to do it, because I know I could ask one of my colleagues, what is electrical and computer engineering, but they're not going to reply, I know. So I thought I spent a lot of time thinking about a nice sentence that summarizes what it is, or the importance that it has in the present world. And that's after some dialogue with the ChatGPT, we came up with that sentence. It's the lifeblood and the nervous system of a modern world. It's not just a modern system. It's not just a nervous system. The nervous system in our body is about information and stimulus and all that. It is that too. But it's also lifeblood, because it's also about energy. And so it's everything. It's information, it's motion, and it's also energy. So everything starts with energy, of course. Since we're talking about electrical stuff, and computers are also electrical stuff, we need electricity, and so everything starts with power generation and power distribution. And we have, of course, transportation, which is also modern transportation. All of it is electrical, right? And industry. Industry is basically electrical. All the machines are electrical. And then we have the things with which you spend all your waking hours, computers and mobile phones. They're electrical and electronic, right? And if you, fortunately, I hope none of you is in need of going to a doctor, but if you go to a doctor, hospitals nowadays are huge, very complex electronic systems with medical imaging and all sorts of medical devices. They're all based on electrical stuff and electronics. So all of modern medicine is fundamentally electric and electronic. Illumination. So we could have modern life without light, and light requires electricity. We would go back to the 19th century, to the 18th century if we had to go back to gas lighting. Modern transportation, like electric cars, self-driving cars, so getting a bit more sophisticated. It's all about electrical and computer engineering. It's all about electronics and computers and control. All modern transportation, including airplanes. Airplanes are very complex systems from an electronic point of view, and from a control point of view, and from digital communications point of view, and from all sorts of navigation, communications, all sorts of things that have to do with electrical and computer engineering. Of course, mobile communications. Of course, it's the backbone of the modern society. Large computers, so data centers where you all have your photos stored somewhere. Space exploration, satellites for communication and for Earth observation. It's all about electrical and computer engineering. Entertainment. There's the Foo Fighters, right? They're playing electric guitar, it's being recorded. You have it when you're listening to it, you're using electronics, signal compression, playback, storage, communication. Cameras are filming, what's his name? Dave Grohl, right? So entertainment is basically about electronics and electrical stuff nowadays. TV, of course, it's electrical and electronics. You've got a soccer match, football match. It's all about electronics, illumination, all sorts of communication devices. Agriculture. Modern agriculture is basically moving towards autonomous systems that do most of the things that used to be done by people. And now they're being done autonomously. There's robotics in agriculture. There's vision. There's image analysis. There's communication. There's navigation. These machines have GPS systems to know where they are. So all of the modern world. So, of course, deep sea exploration. So underwater vehicles. All of these is electronics. And even the most recent things like AI, generative models are based. So this is essentially a reverse computer vision system that synthesizes images using methods and techniques that have, of course, everything to do with electrical and computer engineering. It's based on signal processing ideas, machine learning ideas, of course, running on computers, and computers are electrical and electronic. So if I had to end here, this would already be enough. I think you should have enough here to stimulate into thinking that whatever of these things you find interesting, there's something for you in electrical and computer engineering. Okay, so before going into more detailed things, let's start with something which is really, really important nowadays. I think we're all worried about these, about climate change, and about people are worried about energy transition. How we can transition our societies from fossil fuels and from pollution to a more green world where these problems are solved. And this energy transition was a very timely article written by our colleague Pedro Carvalho in August. It says, electrical transition, the energy transition is electrical. So it can be seen as moving things from whatever to electricity. Okay? And this is a very important problem because the infrastructure of electricity production and distribution is not up to the task of supporting the energy transition. This is known. And so in this article, I'm not going to read it all, what he says, but he says it's in Portuguese, but we need to attract talent to engineering and explain to young people that are interested in decarbonization of society that is as electrical engineers in the conception, in the design of networks and interface systems and all of that, that they can contribute to the success of energy transition. Okay? So this is a very important idea that energy transition is electrical. So everything has to do with the electricity. Electricity is the blood, the lifeblood of modern societies. So, from a more organizational point of view, so the department is involved in several MSc programs. electrical and computer engineering. It's probably the biggest one and the one that's been our most core master program, but we're also involved in aerospace engineering, data science in engineering, electronics engineering, telecommunication and informatics engineering, and energy engineering and management. So the MEC, MEAR, MECD, MEE, MET, and MEsh. So we're all involved in all of these. So you can work with people from DEC if you follow any of these master programs. They have different natures and different styles and different, you'll be able to ask about that later on. And in terms of research, the Department of Electrical and Computer Engineering is closely associated to these three institutes. So the Institute of Telecommunications, INESC-ID, which has a very long name, which I never know by heart, and the Institute for Systems and Robotics. Okay, so we're all, I think, all of the professors of this department are working in one of these institutions. I don't know if all of them, but at least almost all of them. So now, the other part, why DEC? What can you learn at DEC? What can you work on at DEC? So these are important questions. And now what I'm going to do is show you a few snapshots of things that have been done in recent years as master theses supervised by DEC professors in one of those master programs that I've just mentioned. I don't know each one of them actually, so it's not very important actually, but so let's see. So modern robotics. This is one very interesting work. Let's see if it plays. Let's cross fingers. Yeah.
Following the trend of recent years, robots will continue to play a major role in our lives.
This is a thesis about...
While traditional robots already excel at precise repetitive tasks, we are now moving towards more adaptable, flexible robots for many
How do I mute
applications.
this? There you go.
When we look at nature, we see mostly software.
Yeah, okay. So this is a thesis, a recent thesis. Maybe Gilberto is sitting there. You were the supervisor, right? Right. So this was a thesis about designing robots that are more similar to natural beings in the sense that they are soft and they are flexible. Rather than articulated arms, they behave more like natural beings, like fingers. So this is a very modern trend in robotics, trying to design things that can do things that standard robots cannot do, like pick up very fragile objects, such as fruit, for example. And the inspiration is from nature, of course, in this case, and it's based on an idea called babbling. So babbling is what babies do when they're learning to speak, like doing sounds to try if things work, what sounds will work. And motor babbling is the same idea, but there you go, sensory motor babbling. Same idea, trying different gestures, which also babies also do, to try to learn how to handle, how to control these flexible structures. This is a longer video, but I'm going to skip it because it's more technical after that. Okay. So satellite communications, very different topic from robotics. Okay. So this is a master thesis that was supervised by, I think, Paul André, right? You are. Which is about, so it's one of the difficulties in using satellites for communication is it's the communication part. And this is a thesis, I'm not going to go into details. If you have questions, you should ask Paulo. About how to use optical connections to connect the ground stations or even between satellites using optical communications. By optical, I mean laser communication. So we'll just wait a few seconds. We'll see a laser beam beaming up to the satellite. There you go. There's an optical system. There you go. There will be a laser beam shooting up right now. There it goes. All the way to a satellite. Okay. So there's lots of advantages and also challenges on in using this type of system. And actually, this master thesis was about addressing and studying some of these challenges. Of course, it doesn't make any sense for me to talk about in detail about any of this. Just to give you an idea, the kind of thing that could be a topic of a master thesis in this area. Okay. Should move. So autonomous vehicles for environmental applications. I don't know who supervised this. Maybe it was Rita or Pedro. It was you, Pedro. No, maybe Rita. I don't know. Okay. So the idea here is to cooperative motion control of aerial marine vehicles. So this the problem here that's being addressed is is oil spills, how to deal with oil spills. You all know what oil spills are. Sometimes the boats will, for some accidental cause, will spill oil into the ocean, and then it's necessary to clean up. And cleaning up the oil from the sea is a very hard task, very hard mission to do, and it's impossible to, and it would be very useful to have aerial vehicles looking down and seeing where the oil spill is, and simultaneously having vehicles, remotely operating vehicles on the sea, everything talking with everybody and somehow coordinating the task of detecting the spill, localizing it, and controlling what the fight against these and handling the oil spill. Okay, this is another. So it involves control, and so it could be you, Pedro, right? But it's not. It's probably Rita Cunha, yeah. So another type of thing. Okay. So this one is avionics. So avionics is all the electronics that is used in airplanes and also in space flight. So there's a lot of master theses. This is not specifically one specific master thesis. It's just a small video that shows that avionics is something that is done at DEC. So this is examples of antennas, for example, for avionics, and control systems and communications. All sorts of things have to do with that have to do with avionics are studied at DEC. So Internet of Things. Maybe you've heard about Internet of Things. So Internet of Things is this video is actually nice. So this is work again supervised by Paul André, who's sitting there. Smart optical sensors for Internet of Things. So the idea is to integrate temperature monitoring into like wearable devices, for example. So it's another topic. So it has to do a little bit with materials, but also with communications, of course, always with electronics and everything that has to be done to solve these kinds of problems. Medical applications. There's a lot of different theses on medical applications. This one is about Alzheimer diagnosis from both images and other clinical data. So again, not going to go into the details. So each one of these would take like 20 minutes to explain in detail. Of course, the video does it in like 2 or 3, but it's a small summary. So this is a thesis supervised by Margarida, I guess. Yes, Margarida Silveira from ISR. So medical applications. So the idea here is to improve the diagnosis of Alzheimer's disease by combining different types of data. So this is essentially a machine learning problem, but applied to a very specific application, which is a medical application. Here we go. Next one. So maybe you've heard about these, the IST-SAT-1, the little satellite that was built at IST. Around this satellite, I was talking to Rui yesterday, who was in charge of these. He told me that there have been already more than 30 master theses around the building of this satellite, mostly from electrical and computer engineering, from aerospace engineering, from METI, from ME, from electrical electronics. So from different masters, and I think one from mechanical engineering, but I'm not sure. And this is I think it's going to be launched very soon, right? Do you know? Rui? I think it was scheduled to November this year, Ariane 3 or something. So it was delayed because of the pandemic, and so this actually it was on the news. Okay, so maybe we can hear this one.
Satélite vai ser colocado em órbita em
it's in Portuguese. I'm sorry.
Should I cut it? Espacial Internacional. O satélite do Instituto Superior Técnico foi escolhido pela ESA, a Agência Espacial Europeia.
Let me move ahead.
Faz 60 anos que foi lançado o Sputnik. Quais?
E ainda não está aqui, ainda não foi fabricada, mas vai aparecer aqui na
So that's a satellite. It's a small cube.
E os painéis solares.
Tomás fala do protótipo do IST Nanosat-1, pioneiro em Portugal. A construção, a preparação para o lançamento e a futura monitorização do satélite são da responsabilidade desta equipa portuguesa e universitária.
Okay, this is just to give an idea that a little satellite like this is a very complex system, and to develop it, it justified more than 30 master theses. So it's a lot of work. There's lots of different aspects inside the satellite, and it's a very interesting example of a hands-on project-based learning experience that actually was very successful and very interesting. Okay, let's move on. More satellite stuff. This one is yours, right, Pedro? Yes. Okay. Distributed decentralized control for very large scale systems applications to LEO. So LEO are low Earth orbit mega constellations. This is about the problem of how to control all these small satellites. It's complicated because there's lots of them. It's a very complicated control problem. And so there was, again, a very interesting master thesis supervised by Pedro Batista sitting back there on these. So I don't want you to really look very much into detail of each of these examples, just the idea of the variety of things that we cover that you can work on. So this is a little video that Pedro Lima sitting there sent me. This is it's not so easy to understand what's going on. So this is a competition that happened. When was that, Pedro? This year? July. So it doesn't, you don't understand from the video, it's not clear, but this robot is taking instructions in spoken language and say, do this, do that, and is obeying and controlling. And it actually got an award, is that right? Yes, so it's again, state-of-the-art research in robotics being done by people from DEC. So another very interesting application. This is from Carlos Fernandes, they're all from our department, from IT, which I hope is loading, is how to detect plastic in the ocean using either satellite or other types of aerial or spaceborne or airborne images using microwave sensing. It's very interesting. I'm gonna run ahead because there's a part of the, let me see, of the experiments which are quite interesting. So there's a problem with plastics, all of that, and so there you go. So that's the kind of, this is research work in this area. You have to go on a canoe. So those are two students towing a lot of bottles to run the experiments. So if you work on these, you get to do some water activities. There was a nicer picture. Yeah, it's this one, I think. There you go. There you go. Unless you're afraid of the water, this is nice work. Another project by Carlos Fernandes Group is microwave imaging for breast cancer diagnosis. It's a new method. It's a new medical imaging technique that does not use ionizing radiation nor ultrasound. So this is supposed to be much less expensive. It's being developed, so it's really cutting edge research for breast cancer detection using again electromagnetic theory and signal processing and all sorts of modern stuff. So it's built, it's being tested. It's if you want, anyone is interested, you can go to the ECE building and downstairs, and you can see this equipment and ask for an explanation. Okay, I'm going to skip this one. Okay, this now it's not video, so other applications of this kind of systems. Again, these are all that I've showed are master theses in one of these master programs that I've mentioned. So this again is from electrical and computer engineering. It's a system it's used for sports to do stroke analysis for competitive swimmers. So it allows the coaches to analyze the performance of each of the swimmers by analyzing its motion patterns, and it's a kind of application that is also very interesting. So another one, well, related to that one, which is the interface between electronics and signal processing and machine learning and applications with humans. It's this electromyography-based onset detection of different things. One of them is for helping disabled people interacting with electronic devices. So this is again another master thesis supervised by Carlos Almeida and Rui Rocha in this case. The other one was Hugo Silva. So now because I know you should also talk about your own stuff, so I'm going to talk for 2 or 3 minutes about my own stuff, what I've been working on in recent years. So I'm on focus only on master theses that I have recently supervised, on what topics I'm interested recently. So just the last 2 years. So one of the most interesting master theses I co-supervised, it was 3 years ago, with our colleague, he's not here today, André Martins, and the student Gonçalo Faria. It's what the thesis is about, something called causal discovery. He got the Luís Vidigal Award and the Best Master Thesis Award, and it's about causal discovery. And I'm going to give you a lecture in 2 slides about what is causal discovery. So causal discovery is solving this problem. Suppose that you know, you have some observations, and you've noticed that it's common to have these 3 things happening together: drinking a lot, waking up with your shoes on, and having a headache. Okay? And any human, even a little girl, would understand that, well, obviously you drank too much, so you woke up with a headache and with your shoes on because you didn't have time to take your shoes off. But it's not obvious. That's obvious for a human because we know how the world works. It's not obvious, and it's not easy to make computers do this kind of inference. And so causal discovery is precisely how to automate this kind of inference that's so natural to humans. And it has applications in many areas. For example, it has applications in explainability and fairness. So in the past few years, I've been supervising a lot of master's students in collaboration with FIDSI. That's a company that works in financial fraud detection. So this was João Bento, who was a master student who worked on one problem of explaining. So explainability and fairness in machine learning, it's kind of self-explanatory. So machine learning models, AI, make decisions, and it's very important in critical applications to have the system explain why it made that decision. Okay? One of the reasons why this is important is because we want this decision to be fair. For example, to be fair across, say, racial groups or ethnic groups or age groups or whatever groups we want. Okay, so this is a very interesting thesis that came out of our collaboration with FIDSI. Explainability and fairness in machine learning is a more recent one. So this one was 2 years ago. This was last year. José Pombal, again, we produced 2 papers on this topic. Again, fairness-aware machine learning. And currently, so this was also last year. Currently, we're still working on this. So these are human AI collaboration. This is another interesting topic that I'm interested in right now, which is how to have machine learning systems and humans collaborate in decisions. There are many areas where this is very important. For example, in medical applications, where you have a human expert being helped by AI, how do they collaborate in the most efficient way? And this is a topic that, again, all of this is in collaboration with FIDSI, and it's turning out to be a very successful collaboration. So, in the end, I just say, come study, work, and have fun with us. This is all the people at the department, and that's it. Thank you very much. I'm ready for questions if you have questions. Pleasure.
Talk. Now the questions for the audience. Please, if somebody has, please ask them. Yeah? Nobody asked questions? I actually have one. So,
sure.
Can we study artificial intelligence in one of the department's masters?
Yeah, of course, yeah. So at least in MACD, in Master in Data Science and Engineering and Electrical and Computer Engineering, we have the deep learning course, which is essentially an AI. That's what modern AI is deep learning. So we have machine learning, the machine learning course and deep learning course. And there's also, I think there's actually an artificial intelligence course, I'm not 100% sure. But at least the deep learning course, yes. Actually, it's a joint course between DEC and DE. Informatics and electrical and computer engineering, yeah, you can, for sure. All of these masters, all of these that I've showed, this is all AI, right? This is all what's modernly called AI, right? This is all AI, machine learning, but AI, okay? This is all AI. Yeah. Back there.
Yeah, they're asking me to just put the microphone on. There's a question there? Yeah.
What would be your advice on how to choose the right advisor?
Wow. That's a good question. I don't know. Let me think. So the relationship between the advisor and the advisee is a complicated relationship. It has, of course, technical aspects, but it has also personal aspects. So you should choose someone that, based on the topic, so you have the offer, the listing of all the proposals, but it's also important that you work with someone with whom you have some empathy, that you found interesting in lectures before, or that you think you'll get along well with, because you'll have to work with that person for 8 months, at least on a weekly basis if things go well. And so it's important that it's someone with whom you don't have some, let's say, antipathy, or someone my advice, which is not obvious, and it's maybe not what you would expect me to say, it's important that you think it's someone that you can relate to. Maybe sometimes it's even more important than the topic.
And if I actually want to pursue some of the master theses that you just showed, what do I have to do?
No, these are all gone. These are all finished.
Okay, there's...
Total, there's offers, yeah.
Okay. Yeah. The microphone.
Yeah.
People at home.
So recently, with the change of our whole university, I think the Department of Electrical Engineering has adapted very well to new technologies, like introducing a lot of machine learning courses. Do you have any idea of what would be the next innovations that might happen with the introduction of new themes for studying?
Well, that's hard to predict, especially the future. So I think you mentioned machine learning. So machine learning is kind of nowadays sort of what it's an extension of what mathematics and programming used to be. It's just another tool that you can apply in many different areas. Mm-hmm. And so I think that one thing that we should do is also in electrical and computer engineering is have a machine learning course at the undergrad level, like the informatics department has, so that because it should be seen as a foundational tool that you cannot get away without, because almost everybody is using in all the areas. It should not be seen as a specific area of electrical and computer engineering or informatics, but as it's like an enabling technology that you use to do everything. People who design electronics use machine learning. People who do video coding use machine learning. People who do whatever, you'll use machine learning almost everywhere. So it's like mathematics used to be. You still need mathematics, but you also need machine learning these days. So that's an expansion. You need to expand.
I agree, because I took this course and I thought that we could definitely take it earlier, and that would be interesting for a lot of people that have no idea what this field is, and then they can choose it on the masters.
Yeah.
Does anyone has a question?
Yeah. How can we, as electrical engineering master students, be an active agent in sustainability?
Well, but there's I'd say the default answer would be as a citizen, right? Being a responsible citizen in that perspective. But from an electrical and computer engineering perspective, you can work on sustainability things like low consumption electronics, making computers use less energy. So there's a lot of concerns. So there's a lot of colleagues here who know much more about that than me. Maybe Lionel should answer that. So how do you make computers use less energy? How do you build data centers that use less energy, or that require less energy to cool down? How to make a better electric vehicles? How to develop the energy distribution network so that we can have more electric cars. If all the cars became electric today, it would not work, because our grid does not support charging all the cars if all the cars were electric. So there's a transition. So you can work in areas of electrical and computer engineering that are involved in this transition to a new energy model. That's one answer.
Just a short question. How can master students can take advantage of the outstanding research institutes that you have associated with that?
They already do, right? Almost all the master theses.
How they can?
Because as far as I know, most, or if not all of the master theses are done in the context of one of these institutes. So they are already taking advantage of that. So almost all the projects that corresponds to these master theses, almost all these master theses are part of some bigger project, of some bigger research area that's being carried out in one of these institutes. So by doing a master thesis with people from DEC, you will be almost always automatically inserted, or you'll have the experience of doing research in one of these institutes.
Can I ask something? So everybody is talking about nowadays machine learning and artificial intelligence, but has the fundamental science really has changed over the last 30 years, or is it just something that we have much more computer power and data available?
Fundamental science of what?
Of the methods behind machine learning and artificial intelligence.
The fundamental science, I would say, that has not changed a lot, but the sociological and organizational aspects of machine learning changed a lot, dramatically. So there's actually a recent paper by a famous researcher where he proposes that we use this expression called frictionless reproducibility, which is what really changed. Was the fact that reproducibility is a core idea in science, right? When you write a paper about anything, it doesn't matter what it is. Whatever that publication, that scientific result states, should be reproducible by other researchers. And in most areas of science, it's very hard. So in biology, it's hard because in sociology, there was a crisis of reproducibility in sociology, because there were some study that showed that more than 50% of the papers were not reproducible. People tried to do the experiments again, and they didn't find the same results. So reproducibility is key. It's key for many things, for credibility, because if it's reproducible, then you gain confidence in the results, and it's key for rapid improvement, because you can take that result, reproduce it in your own group or your own computer if it's not too heavy. And from there you can start and improve it a little bit, okay? And the fact that in machine learning in the past 10 years, reproducibility became extremely frictionless, extremely easy. You can go to GitHub, download code, try it, improve it a little bit, and so there's thousands and thousands of people doing that. And so that created like almost a phase transition that created a huge explosion of improvement. And there are several, I could go on and on talking about this because it's a favorite topic of mine. Why this happened? There are many reasons. One of them was the sort of fortunate fact, I would say fortunate coincidence, that the methods that turned out to be more efficient to certain class of problems, such as convolutional neural networks, ran very efficiently on a specific type of hardware that had been developed for another purpose, which were GPUs. And when people found out about that and exploited that idea, it was a qualitative jump. And then at the same time, there's an economic reason, because the big players on the internet, the companies that do search, like Google, the social media, the social media and social network companies, Facebook, Twitter, all of those, YouTube, they needed to, their business models needed machine learning. And so they invested massively in machine learning at the same time. So there was this confluence of factors that created an explosion in machine learning.
What is your opinion about tools like ChatGPT and
Oh.
and the academic population?
Yeah, that's a difficult question. I think the jury is still out. I don't know. I think it is already having an impact. I think we need to change, and I think we need to change our perspective. I think we need to change the way especially the way we assess students. I think that's very important. I think the fact that it's so, for example, and I think even for us, it's not the worst case. So for technical courses, for technical programs like engineering, it's easier to assess if a student knows what to do and understands things. But if you in more humanity-like programs where it's based on writing reports, and it's very difficult to assess if it's originally or not. If it was done by a large language model or not, then it's very difficult. I think in the end we'll have to go back to oral examination, actually talking to the people and asking questions and to assess if they understood or not. So there, I think it's happening very fast. I don't have a very clear question, a very clear answer, but I think it's a very important thing that's happening in the world right now. Yeah. And it's affecting a lot of people.
Any more questions?
So, any of you using ChatGPT? All of you? Yeah. It's also very good. It's also very good because you have like a private tutor. Okay, every one of us can have a private tutor. I use it. Can you please summarize in 10 bullets the main differences between this theory and that theory, and it will do it quite well. And then you can check if it sounds good. Usually it's okay. So it's very good. Can you please explain more in detail this or that? It will do it. So it's a lot. It's like there's a lot of knowledge in there. Knowledge, whatever that means. It's a loaded word, but it is. In the coding, of course, I know companies who are based in doing coding. They are pretty scared because it's easy to do coding using Copilot, and ChatGPT will help you very fast. I had to write something a couple of weeks ago in a language that I had never used before, and I could do it in like 2 or 3 hours with the help of ChatGPT. And in the end, it was working. And I had never coded in that language before. Just for fun, just to try it out.
Does anybody have any more questions?
Okay, so in the various areas that the department provides, there are some ones that are clearly way more popular right now, or more chosen by students, especially on our electrical engineering masters, and that's probably a consequence of like how the world is evolving, at what themes are hot right now. But how is there any way or like any straightforward manner in which we could balance out and attract more students to another like less popular areas, like telecommunications, for example, which I think is less popular, or the energy area, for example?
Yeah, so there are different answers to different. So telecommunications, I think one of the problems is that it's telecommunications is a vertical, like in the language of organization of ideas. It's a technological vertical in the sense that it's an application area. It's not a technological area. So telecommunication involves everything from physics, from antennas and from optical fibers, all the way to operating systems and network operating systems and so I think it should be sliced. If you try to create someone who's a telecommunications engineer that knows everything from the physics of optical fibers all the way to the higher levels of networks, or even to application layers such as video coding or something like that, it's not going to be easy because they're intellectually very different areas. So I think what we need is a better organization of the division, and people who actually like the physics aspects, who should study those physics aspects. People who like network aspects should work on network aspects. And so not try to and energy again is the same. So energy is also a very deep vertical. It goes all the way from electrotechnical, so from the physics of electricity and production of electricity, how generation works and how cables work and all of that has to do with the physics of electricity, all the way to economic aspects. How do you do pricing of energy? And they're very, very different from an intellectual and technical point of view. So I think we need to rearrange the way things are studied to make it more coherent. I think that's a problem.
Thank you. Yeah, we have another question.
IoT useful in what?
Healthcare.
Oh, maybe I'm not the best person to answer that. So healthcare. So in portable devices for sure, right? In surveillance for elderly people, for example, to detect events at home. Well, actually, recently, I didn't mention it because I didn't have a video or a nice picture of that. But there was a master thesis supervised by Hugo Silva, who actually is not in the department, but he could be in the department. That's a lamp for a home of elderly people. That's a lamp that non-intrusively detects if the person fell, for example. And it's a small lamp that has an internet connection and a little camera, and it non-intrusively detects if the person fell on the floor, and it will sound an alarm. So you can equip all your environment to make it safer, for example, and to detect anomalous events and to sound alarms. So that's one possible application. But there are many others, like wearable devices. Non-intrusive, so another area, so Ana Fred, who used to be in our department. Non-intrusive health monitoring, for example. So how can you do, so Paulo also worked a bit on that in some aspects. How can you monitor the health condition of people who have, for example, heart problems without having to install the electrodes and so on? So one interesting solution they have is toilet seats, right? You have a toilet seat with electrodes. Every time you sit down, your heartbeat is being monitored, and not yours, but it's for elderly people, basically, without intrusion, without having to sit the person down and say, now you're going to take an ECG and see if your heart is okay. So every time you sit on the toilet seat, there you go. Yeah, so there's many different types. Yeah, you can. Yeah. This was the first thing that came to my mind. There are countless applications, countless examples.
Professor, if that's not too personal, what's your most challenging project? Or what was your most challenging project?
Where? My challenging?
Yeah.
I don't know. From a technical point of view or from like general point of view? I think the most challenging thing for a professor who's supervising students from that perspective, well, when they teach it, so the teaching and supervising have very different challenges. In supervising, the main challenge is keeping the student motivated and trying to learn something from them and keep them and also teach a little bit and essentially keeping them motivated and work. So that's the main challenge, I think. It's keeping them happy and wanting to do the work. So that's why I mentioned the emotional involvement is very important. When you have meetings, the meeting between the student and the professor should not be a boring meeting. So I have to go meet the professor. He's such a boring guy. So it should be something nice, and it should be a nice interaction. So that's something that I think a lot about. Okay. Trying to be nice.
Any more questions? No? I guess this is it then. The end of the second session of the technical MasterTalks. Don't miss the next one. The next one is dedicated to the Department of Informatics, the Department of Computer Science and Engineering, with Professor Arlindo Oliveira on artificial intelligence, machine learning, and bioinformatics. You can already sign up. Thank you, everyone, once again. I encourage you to go outside to the atrium and meet some of the representatives of the department's masters and get to know a little more about each of them. So thank you, and that's it.